All right, line A6, learning task 7. We are now moving on to the third diagram that we have inside there, which is where we're going to go and take a look at a light dimmer that has been done with a diac and a triac. One of the first things that you should note about this is that it is a very, very similar sort of drawing to what we saw in one of our earlier learning. Learning task 6 had almost an identical drawing with an almost identical sort of error inside of that. And you should be able to recognize that at this point. Now look, we need to go and have proper voltage applied to our control circuit, and we just need to go and control our light. And our light doesn't have to be in line with this. We're going to get rid of that. We're going to move our light over to this side over here, so that our light is now being controlled by this device over here, which you should recognize as being a triac, and we'll just go and draw a line all the way through that. Okay, so this is where you should have had that all moved inside of your book. You can go and do so inside of your own book so that it looks similar to this. As far as the explanation goes off of this one, it's very simple. We are looking at almost the same thing as what we had in previous ones, like the battery charger, where we are just going to be looking at building up a value of voltage onto our cap. Same deal as before, RC timing circuits. We see that we start to build electrons there. We drive electrons away from here. Those electrons are then going to travel through here. If we go and dial this resistance, we're going to go and have a little bypass route. So the bulk of our electrons are going to be able to travel like that, and then through the remaining resistance. We've talked about having this first resistor in series before. The point of that resistor is just so that we don't ever drop our resistance down to a zero value, which would be like a short circuit. So we're going to have electrons that are going to flow through here. From here, then they're going to go and flow back to our main source over there. That line disappeared again. That's okay. We'll just draw it again. Anyways, it's going to travel through like that. And as it does, as it builds these electrons onto here, we're going to see that value of voltage rise until eventually it is going to go and hit whatever we have for a trigger voltage off of here. These are once again going to be set by the manufacturer. As soon as we hit that triggering voltage, this thing is going to go and break over, which means it's going to go from acting like an open switch. It is then going to go and act like a closed switch. And once it acts like a closed switch, it is then going to go and gate, give us that little pulse that we are going to have over here. On that gate, that is going to go and gate our triac. Where do the electrons go? Well, the electrons are going to go and travel from here because our voltage has broken over. They're now going to be able to go and run through here. And as long as there's a sufficient amount of electrons running through here, we're going to maintain that holding current off of this diac over here. So this is going to go and discharge. My triac over here, as soon as we give that little gate pulse, is going to go and turn on, and it is then going to allow us to go and get whatever portion of our alternation that we had. If we waited a little bit to go and gate this thing, we would be able to go and transmit this portion of that first alternation, etc. Then our AC is going to go and change, and when our AC changes direction, for the first one here we had a negative positive like that, now we're going to go and alternate that. This will become positive, this will become negative over here. Remember that anytime we hit that voltage, this thing is going to have discharged itself, and then it's going to go build up, discharge, build up. So it might do that multiple times inside of this circuit, that we're going to go and see this circuit build and discharge, but it's always going to stay at a relatively low level. When we change our direction, all that's going to happen, now we're going to start sending electrons in from this side down here. They're going to fill those holes. They're going to drive electrons away from out over there. As they do so, then we are going to go and start to build our electrons in the opposite direction. Build, 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 like that. And as that happens, we're going to get closer and closer until once again we hit the same firing voltage. Once we hit the same firing voltage, it is once again going to go and gate this, and this time we're going to drive main load current through in the opposite direction. Because this is a complete true AC circuit, the other ones that we were looking at before were rectified DC circuits, the previous two in this learning task, but because this is a AC circuit, we have to go and use AC compatible devices. Both the diac and the triac are AC compatible devices that can deal with the switching back and forth of currents through them, as well as they can deal with the the voltages that are going to be impressed across them in opposite directions. Some of our other components wouldn't do so well with this. If you go back to what we looked at the previous one here, the battery charging circuit, we had a component in here, the zener, that acted very similar to the way that we've got this diac over here. But in this case, it was a rectified DC, so we could get away with that zener. We said this zener could have been replaced with a diac for this circuit over here. because if I want, I can go and place a diac into a DC circuit. If pulsating DC is still going to act the same. But what I could never do is I would never be able to go and place a zener inside of here. No zener. Okay. We have gone over this one before inside of Learning Task 6, so I'm not going to go beat this one to death. We're going to move on now to the light dimmer using the UJT.